Okay, welcome back to the next part of my Voyager style grand tour of the outer planets. In the last video, we brought the Aero Freighter from Saturn all the way over here to Uranus. And it's actually been a few days since I recorded the last part, so let me take a moment to familiarize myself with exactly where I'm at. That's right, we're just a little bit past periapsis here at Uranus. And we are going to encounter Neptune on this date, roughly. So let's find out when that is. So that's going to be 116150. So that's going to be November of 2176. So we've got another long time warp phase here ahead of us. I think what I'm going to do in this video is I'm going to go ahead and skip the time warp. I feel like this mission, being quite long, we've had plenty of time warp between Earth and Jupiter, and between Jupiter and Saturn Saturn to Uranus, so I'm not going to record the whole time warp phase going out to Neptune, because it's going to be maybe 35 minutes just of time warp. So let's go ahead and warp time ahead here a little bit though. Start heading out away from Uranus over to Neptune, because we do need to do our initial mid-course correction. So I'll definitely go ahead and record up to that point, and then we'll pause the video, and then we'll pick up when we get a little closer out to Neptune. Because nothing's going to change, between one planet and the next. Everything that you saw me do between Jupiter and Saturn, and between Saturn and Uranus, is going to be the exact same thing that I do here. So you're not going to miss anything. I'm just going to go out a little ways and do a couple of small corrections as needed. But we will, again, I will record the first one here, because that one comes up fairly quickly when our gravitational influence from Uranus drops down to, close to zero. Then we'll set up our first mid-course correction. And that's usually the biggest one. The first couple of mid-course corrections that I did, having, left Jupiter going to Saturn, that was something like 400 delta V, and then the one between Saturn and Uranus, I believe, was about 600 delta V. So we'll see how large this one's going to be. Go ahead and put time warp all the way out to maximum now. So we're moving quite quickly, and we'll get Uranus in the rearview mirror pretty quickly this way. And a couple things we're looking for. Again, when the gravitational influence drops to near zero, then this stage will update. We'll come out of the stage 1 slingshot, and then we'll be in stage 2. Well, basically stage 3 becomes stage 2, and stage 2 becomes stage 1. And that'll happen here in just another maybe 30 seconds or a minute. That's what our Neptune encounter is looking like right now. We're still quite close, relatively speaking. That's out toward the orbit of maybe the moons around Neptune. It's not too far out. But we're getting close to that point where this stage is going to update. And there we have it. So let's come back to 1x. Looks like the gravitational influence of Uranus was down to 0.03 when that happened. Now there's actually something I want to do here before I set up the mid-course correction, the maneuver. What I'm going to do is press Control S to save the scenario right here where I'm at, which is November 28, 2169. And I'm actually going to exit Orbiter. Let me set that date converter to the side. Let me close that out. And just give me one moment to do a little bit of scenario maintenance. I'm going to move that quick save scenario over to my folder where I've been keeping all these Grand Tour scenarios. And we're going to call this scenario Neptune. Let's call it First Neptune MCC. Now I'm actually going to start the DirectX 7 version of Orbiter because I want to be able to use the Orbit Lines add-on, and I can't use that if I'm using the D3D9 client. So there's the scenario. Let me go ahead and launch Orbiter. And I want to take a good look at Neptune really quick. There we go. And these are the lines that I was talking about. This is one of the add-ons that you can get for Orbiter that shows the lines. It's called Vidini or Vindini or something. I just call it Orbit Lines. But it shows you the orbital path of moons around a given body, or it even shows your orbital path of your own vessel around a body. But we're looking at Neptune, and in the default orbiter installation, Neptune has 3 moons. It has Proteus, which you can see is in there really close to Neptune, and has a nearly equatorial orbit around Neptune. Then we have Triton, which has this quite inclined orbit, and it's out there quite a bit farther than Proteus, but it's still relatively close. And then we have this weird moon Nereid, which you can see is very inclined, and it orbits Neptune at a very elliptical orbit. It passes in somewhat close and then goes way out on that side, so it's very elliptical. The moon that I'm going to go for in this Grand Tour, when I finally get over here to Neptune, is Triton. And there's a couple of reasons for it. I guess the main reason is that Triton it's the largest moon of the 3. Proteus, I believe, I looked at all 3 of them and I don't remember which one was smaller, but I believe Proteus was the smallest of the 3. It's actually kind of like a Phobos. It's very, very tiny. Now, the easiest one to get to, though, would arguably be Proteus, because we're headed toward Neptune at a low inclination, either prograde or retrograde. Either way we want to go, we're going to have a mostly equatorial orbit around Neptune by the time we get here. So in terms of showing up at Neptune and being already in plane, Proteus would be the easiest. And that would be similar to when I went to Jupiter and landed on, Europa or Io, those moons are close to an equatorial inclination around their parent planet. Now, this is important to note because if you want to take advantage of something that a couple of people pointed out way back in my Learn With Me's that I did when I was going to Jupiter and Saturn, there's this thing called the Orbith, I think I'm pronouncing that correctly, Orbith effect. And that's when you get in really close to the planet or the target body in order to do your braking burn, but you don't actually circularize the orbit all the way down into a nice tight orbit around the body, which was one of the things that I tried to do at Jupiter. What you do instead is you get in really close to the target object, and then you burn until you close the orbit, until your eccentricity is less than 1, and then your apoapsis is really far out, but your periapsis is really close in. Now, it turns out that doing it that way actually saves you a lot of fuel. It may be a little counterintuitive, but the math doesn't lie. And if you do that burn, that braking burn, when you're at that periapsis, when you're going really fast, it turns out that it closes your orbit much faster. If you remember when I went in my third Learn With Me, when I went out to Jupiter, it was my thinking that it would be best to arrive at Jupiter at an altitude of 1 million kilometers from the target body, and then do my braking burn to get into orbit around Jupiter. And it worked. What I did worked, but it would have been better if I had gotten out to Jupiter with a target altitude of maybe, 1,500 kilometers or 2,000 kilometers, something like that, something really close to Jupiter, and did the braking burn to close the orbit around Jupiter. But I would leave my apoapsis really far out, well beyond the orbit of Europa. So I would have a very elliptical orbit. And then once I was done with the braking burn, I would then, go out from Jupiter. Let's say this is the orbit of Europa. I would then go out from Jupiter well beyond the orbit of Europa, and then I would raise my periapsis back out. So then I would have a circular orbit. And from that point, I could then rendezvous with Europa. That's what I should have did. That's what I should have done. But I didn't know about the Orbith effect back then, so I didn't do it that way. Now, my original thinking for coming over to Neptune is that I would do that. I thought, well, I made that error when I was getting over to Europa from Jupiter, so let's not make the same mistake twice. When I get over to Neptune, let me take advantage of the Orbith effect. Let me get in really tight around Neptune, and then I'll burn until my orbit's closed, and then I'll have my apoapsis well out beyond the orbit of Triton, and then I will go out to apoapsis and raise my periapsis, and then eventually rendezvous with Triton. But here's the problem. If we look at Neptune, you can see that Triton is at a very inclined orbit. So let's think about what would actually happen if I did this maneuver that I'm talking about. Okay, so I come in to Neptune and I do the braking burn really close into Neptune to take advantage of the Orbith effect. Now I've got an apoapsis that's way out here and a periapsis right there. So then I leave Neptune, I come way out here, and I raise my apoapsis on the other side. I raise my periapsis on the other side. So now I'm in orbit around Neptune, and I've got an apoapsis out here, am periapsis over here. I'm in a plane around Neptune that would be more like Proteus. I would have a plane that would be almost straight across. So then I would have to do this fairly enormous plane change to get into orbit around Triton. And I actually don't think that that would be any better. Actually, I don't think that would be better. I don't think that would save fuel by taking advantage of the orbit effect to do it that way. Now, there are a few different options. There are, multiple options that I can go with. And I was actually, talking to Dimitri about how to set this up, and he's actually the one that brought up a lot of these points to me, by the way. I don't want to sit here and take credit for thinking of all this on my own, because I definitely didn't. So I, again, appreciate, Dimitri taking the time to explain all these things to me and make videos to kind of show me some of this thought process. So my thinking here is that what I want to do, while I'm still well out away from Neptune, is I'm going to plan to arrive at Neptune so that I can actually be at Triton when I get here. So instead of coming straight to Neptune, I'm going to plan on arriving near Triton and doing my whole braking burn orbit insertion just when I get down by Triton. Now, I don't think that that's going to absolutely be the very best, most fuel efficient way to do it. In talking to Dimitri, he seemed to indicate that if you combine some things with IMFD and Transx, then you can kind of get the best of both worlds, where you can take advantage of the orb-Earth effect and still eventually get over to Triton, but you have to do a combination of MFDs to do it. At least I think that's what he was saying. I don't really know IMFD at this point, so I'm not going to be able to use that in this video. That's going to be a future thing that I'm going to have to learn. I'm currently talking to Dimitri about trying to learn IMFD, but that's going to have to come later. So I just wanted to show this graphic because I think it helps illustrate what the problems are, when you can actually see the orbital lines of these moons. When I pass Neptune, Saturn, and all of those, I was basically slinging past them on an equatorial plane. And my current trajectory for getting out to Neptune has me coming out here and arriving roughly in the equatorial plane of Neptune. And in taking a closer look at the orbital inclinations of the moons, I can see that arriving here at Neptune and getting into an equatorial plane, retrograde or prograde, it just doesn't really make the most sense to do it that way. So that's the thought process. Hopefully all of that makes sense. So with that in mind, let's exit out of the DX7 version of Orbiter and reload the D3D9 client version. I renamed the scenario incorrectly. Let me fix that real quick. Actually, I'll rename them later. This is the one I need. Okay, so here we are. We're far enough away now from Uranus that our stages have updated, and I want to set up the mid-course correction. So I'm going to go forward on this side, and I'm going to target Triton. Come forward on this side, view the encounter, and come over to setup. Actually, let me come over here to setup and go through, and I want to view target. Yeah, there we go. So this blue line is the orbit of Triton around Neptune, and this blue line points to where Triton is currently at in its orbit, and that actually doesn't really matter at this moment. So back here in stage 1, I'm going to turn maneuver mode on, and the first thing we're going to do is just bring down this rough closest approach, because we're out a bit. And I can see adding positive is not helping, so let's go negative, and that's bringing the closest approach down. And it looks like this is requiring quite a bit less delta V than the other ones were. Okay, now that's showing our trajectory out to, out to Neptune. And just give me a minute to think here. I may just do a burn just to get me here in the ballpark of Neptune, and then I'll worry about fine-tuning my approach over to Triton later, because I'm still really, really far away. So I don't know that it would necessarily do the least little bit of good to even think about doing any adjustments to actually get now. This is the line of nodes, and I do know that whenever we do get actually, never mind that point. Yeah, I'm just going to go with this for now. This gets me in the ballpark of Neptune, and that's really all I need to concern myself with for now. Trying to get everything set up for Triton way out here when I'm still, 8 years out, doesn't really make a lot of sense. But I just wanted to show the idea, using the D3 or using the DX7 client and the orbit lines to kind of show the thought process here going forward out to Neptune, why it's going to be, different than these other mid-course corrections. So let's reset the date to get it current. Not that it matters, we're so far away that the timing of the burn hardly matters. We'll bump it forward here a little bit, and then we'll do an update here just to make sure everything's current. Yeah, that'll be fine.
Translation, rotation.
Okay, and we're doing negative prograde, so we're going to be basically going retrograde. So let's update our orbit. You can see currently it says orbit Uranus, and we're actually in orbit around the Sun now, so let's update that and copy that information to the HUD. Now we're orbit Sun.
Translation. Rotation.
And let's rotate retrograde. And our X should be close to this point. And there it is. Let's fine tune that. And there we are, and we're only 50 seconds away. I could just as well do this burn now, because we're still so far out that a few seconds isn't going to matter, but let's go ahead and wait till we get the countdown since we have it. Burning in 3, 2, 1, and burning. Okay.
Translation.
And that's going to be it for that maneuver. Let's go ahead and look at TransX over here so we can kind of see what we have going on. Again, this is Neptune here. This is the orbit of Triton. That's where Triton's at right now, but its current position does not matter in the slightest because we're so far away that Triton's going to go around who knows how many times in the next 7 years. But this is showing what our current trajectory is out to Neptune. And I'll do just a little bit of time warp here so we can see how things move a little bit.
Rotation.
And then I'll quick save and end this part of the video. And then I'm going to do the long time warp phase. And there you can see Triton orbiting. And our trajectory is holding pretty well. And this dashed line here is where TransX thinks Triton's going to be by the time we get over there. And you can see that it's already moved from there to here. So setting up that maneuver in trying to figure out my arrival at Triton would have been a totally fruitless effort due to just the variations, the permutations, the inaccuracies, everything, being that far in advance. There's just no way it would hold. So that's why I'm not even going to bother trying to set that up until I'm much, much closer. Maybe I'll think about trying to get lined up with Triton when I'm as close as a year, but even that seems, pretty too far out. But that'll be at least slightly, getting in the rough ballpark. So that's basically going to be it for this video, because I've got 6 more years of time warp, and it's roughly 6 minutes per year, so that's 36 minutes of time warping at 100,000 to get out there. And like I said, I've already recorded more than enough time warp stuff for one video. So let me come back to real time, and I'm going to go ahead and quick save here at this point, and I'm going to end the video. And when we come back, I will be maybe a year or 6 months out from Neptune, something like that. So if you have any questions about this part of the video, go ahead and leave those questions down below, and I will see you in the next part. So we've got another long time warp phase here ahead of us. I think what I'm going to do in this video is I'm going to go ahead and skip the time warp. I feel like this mission, being quite long, we've had plenty of time warp between Earth and Jupiter, and between Jupiter and Saturn to Uranus. So I'm not going to record the whole time warp phase going out to Neptune, because it's going to be maybe 35 minutes just of time warp. So let's go ahead and warp time ahead here a little bit though. Start heading out away from Uranus over to Neptune, because we do need to do our initial mid-course correction. So I'll definitely go ahead and record up to that point, and then we'll pause the video, and then we'll pick up when we get a little closer out to Neptune, because nothing's going to change, you know, between one planet and the next. Everything that you saw me do and a couple things we're looking for. Again, when the gravitational influence drops to near zero, then this stage will update. We'll come out of the stage 1 slingshot, and then we'll be in stage 2. Well, basically stage 3 becomes stage 2, and stage 2 becomes stage 1. And that'll happen here in just another maybe 30 seconds or a minute. That's what our Neptune encounter is looking like right now. We're still quite close, relatively speaking. That's out toward the orbit of maybe the moons around Neptune. It's not too far out. But we're getting close. Between Jupiter and Saturn, and between Saturn and Uranus, is going to be the exact same thing that I do here. So you're not going to miss anything. I'm just going to go out a little ways and do a couple of small corrections as needed. But we will, again, I will record the first one here, because that one comes up fairly quickly when our gravitational influence from Uranus drops down to, you know, close to zero. Then we'll set up our first mid-course correction. And that's usually the biggest one. The first couple of mid-course corrections that I did, having, you know, left Jupiter going to Saturn, that was something like 400 delta V, and then the one between Saturn and Uranus, I believe, was about 600 delta V. So we'll see how large this one's going to be. Go ahead and put time warp all the way out to maximum now. So we're moving quite quickly, and we'll get Uranus in the rearview mirror pretty quickly this way. Okay, welcome back to the next part of my Voyager style grand tour of the outer planets. In the last video, we brought the Aero Freighter from Saturn all the way over here to Uranus. And it's actually been a few days since I recorded the last part, so let me take a moment to familiarize myself with exactly where I'm at. That's right, we're just a little bit past periapsis here at Uranus. And we are going to encounter Neptune on this date, roughly. So let's find out when that is. So that's going to be 116150. So that's going to be November of 2176. Close to that point where this stage is going to update. And there we have it. So let's come back to 1x. Looks like the gravitational influence of Uranus was down to 0.03 when that happened. Now there's actually something I want to do here before I set up the mid-course correction, the maneuver. What I'm going to do is press Control S to save the scenario right here where I'm at.